students, I am Professor Golab AM, currently working in the Fulton Education Society's College of Engineering Fulton. Today we are going to discuss about our one experiment from the first year BTech students, which is PN junction diode and their characteristics. In this particular experiment, we are going to discuss about the characteristics of the PN junction diode. We know the PN junction diode means the two type of the semiconductor materials joined together to form a junction. And whenever we are applying the voltage to that two terminals of this PN junction diode, we are getting the various characteristics here. In this experiment, we are going to discuss about the forward bias characteristics of this PN junction diode. So, whenever we are connecting the positive terminal of the battery to the P-type semiconductor and negative terminal of the battery to the N-type semiconductor, this type of the joining, this type of the biasing is known as the forward bias. And in the next, during the experiment, we are applying the various variable voltage to that PN junction diode, and at certain level, it tries to hide that current. In certain level voltage, it does not flow any current in that particular circuit, but after some voltage is applied by us to that particular diode, it starts to flow the current in that particular circuit. So in this experiment, we are going to study these characteristics, the switching characteristics of this PN junction diode. So this is our setup for this PN junction diode characteristics. This is the variable supply, this is the resistance, this is our PN junction diode, and with the help of this connecting wires, we have connected here two measuring devices. First is the milliammeter and another is the voltmeter. So milliammeter, we have the range between 0 to 50 milliammeter, and in the voltmeter we have range between 0 to 1 volt. So in this case, we are studying here, come forward please. In this case, the each and one division of this voltmeter, we are getting here 0.02 volt. So if we flow, or if we do the 5 divisions to that particular voltmeter, we are getting here 0.1 volt. So we will start our experiment. We have to move this knob, and we have to move this knob up to 0.1 volt. We have set here the 0.1 volt voltage, and we have to observe this milliammeter, and there is no change in this milliammeter. Similarly, we are going to the 0.2, 0.3. Now we are going to the 0.3. Still there is no change in this particular milliammeter. In 0.4, 0.5, there is no change in this milliammeter. But if we go to that particular point, 0.6, up to this reading, we have to go directly. But here we are getting now some current in this particular milliammeter. So from this reading, we have to move only the one division. So we are going here to 0.62 voltage and 0.64, 666, 68, and up to we have to go to the 0.7 volt. And as we touch to that 0.7 volt, we are getting here the maximum current which is flowing in that particular circuit. So after 0.7 volt, still we have to go some readings, 4 to 5 readings, and we are getting here 0.72, 0.74, and if we observe this milliammeter, we are getting here maximum current flowing in that particular circuit. Initially the current is flowing only the 1-2 divisions, but now it is flowing for one division of the voltmeter, it is flowing maximum current which is flowing in that particular circuit. So by this way, we are getting the readings of our experiment, and we have to note only the input voltage and output current. And by using this, all the readings, we have to draw the graph, and we have to find out here one quantity which is knee voltage, the voltage at which the current starts to flow maximum level. This is our knee voltage. So thank you very much.